far because then you're running stuff.
And now minimize this window.
You don't really know what's required.
And then at the end of the recording, bring that window up and stop. Okay, great, thank you.
How much power exactly?
I don't think it's necessary, but if you want the microphone.
I can do that, thank you. So world I really live, because we actually have to give a price. We have to give an estimate for the whole scope of the project in order to win the business. And often what we do is we have a, I mean, it sounds terrible, but like there's the rule of thumb and heuristics that we know that at a certain level of effort and an estimate, we can accomplish the objective. We just don't know what the features are going to be. So to the clients that we have, we say we're committed to your business objective. We're going to have a solution that does that. You're not necessarily going to have all features that you're envisioning in mind. So if the business objective is to facilitate or make that publishing process easier, you know, you might not necessarily have the most complex editor to know, but we will make enough for process that your publishers would say is so it's more about changing the features to work within the constraints, but always staying true to the objective itself. And that is a mind shift for a lot of clients. Like a lot of them are very feature centric, and they want the greatest toys or whatnot. And you got to get them to switch over. And if they don't, we just say it's not a good fit. Like you know, the sales pitch, the whole like stand up, dance like monkeys kind of thing. Yeah, we have to do that often, but we like to position around fit. Like, are we a good fit for you, and are you a good fit for me? Yeah.
And then you get the they say
Yeah,
that in
I'm
the
gonna give you my
process
card.
as you're going through the run, you know, the run board. But then when it comes to
Yeah, absolutely. So when is your little? Is it a little conference? Is it a large conference?
It's 10th anniversary.
You know what? That's perfect. Yeah, a lot of people from Canada actually come.
Yeah, they do. It's not business focused. It's the 27th and 28th.
Okay, so
it's
just
on
put it in the
Wednesday,
calendar.
Thursday.
We'll come on down. We have business partners in Boston, so we're down quite often. And I would love to do the talk. And we can even tailor it a bit for more design thinking too, like agile design and how that goes. Very nice to meet you. We'll talk to you soon.
Yep, your best presentation. Thank you.
Love it. Great feedback.
Oh, yeah. Yeah, that's a lot of traveling. Yes, people said to me this day, yeah.
Okay. Thanks a lot. Oh, absolutely. We'll be in touch, I'm sure. We'll keep doing this.
Andrew's here. No, but you can hang my shirt in your closet. How about that? Trying to get out of your way, and I just made 4 minutes. Yeah, seriously though, if you hang my shirt. Your wife. Yeah. They're actually so good. The end. I wasn't at work. Jobs. From front to back. It's actually really
One, two. 1, 2. Can people in the back hear me? All right. Excellent. Oh, but there is a lot of static.
breathing.
That means I'm alive. Okay. In that case, can everyone hear me? All right. I think we can get through to this. Okay, let's start. So welcome everyone to modern JavaScript, an overview of modern JavaScript, not the horrible monster that it used to be. You don't have to be a JavaScript heavy user. This is pretty lightweight. It's just wide and broad overview. I'm Gleb Bahmutov. I've been using JavaScript for a while, and I'm active on all these things like GitHub. You can find a lot of JavaScript that I posted there. I've been doing a lot of C and C++ and C# and Java back in the day, but I transitioned to JavaScript, and you'll see why. And I hope to convince you that you should consider JavaScript a serious language that can do everything that you're thinking of doing in your professional career. My background was in computer vision, so I've been doing laser scanners, image stitching, and so on. I work at small companies and large companies. Right now, I work for a company called Cypress.io. It's an end-to-end test runner. You will see this thing in action. Actually, like right now, basically, if you have a website or web application, you can install Cypress as an npm dependency and see your website, write tests, and you will see how they're running. And then you can go back and see step by step what the result was at each part of a test. So you don't have to think about Selenium. You don't have to bring multiple languages or all that jazz. Most importantly, like why you should listen to me. I have a lot of projects that are really popular in JavaScript. I've written a lot of blog posts about JavaScript and Node.js. So hopefully I know what I'm talking about. Okay. We are not doing rocket science here. We're not trying to land rocket back on the platform. All we really are writing over and over is, getting data from the user, getting it to the server, then showing the UI, showing the same data in our user interface. That's it. Nothing complicated. And yet, let's say 10 years ago, I would use C++, C#, Java, right, to actually write my server. And for UI, I had a choice of things, so I used all of these things to create a website or rich application. So I had to have completely different set of tools for one platform compared to other platform. And so I was happily coding. I was content, right? I was getting paid well. But every time I needed to do something on my server or on my application that I was building, every time I said to myself, hey, I don't want to write this code. I want to find a library that already does it. I hope, or I bet there is something that does what I need to do. Well, finding a cross-platform library written in C++ that you can just kind of drop into your project is really, really hard. It's a nightmare of all different libraries, all different dependencies, right? All the make files. Things like autoconf are supposed to make it easier. But in reality, for a GUI library, but they would never work correctly. And once I found my setup and a couple things that actually are working, I never wanted to breathe, right? Because they'll just stop working once in a while for no apparent reason. And upgrading versions was incredibly hard. It was just like writing or installing the library for the first time. It was incredibly fragile. So, I had an idea at some point, JavaScript kind of works. It's a cross-platform thing. I don't have to write application for OS X. I don't have to write a different application for Mac, for Windows, and a different application for every flavor of Linux. The cross-platform part is already taken care of, right? Browser vendors, and there are a couple, created cross-platform apps. They're called browsers. They run everywhere, and they have a common platform. So I was like, let's do everything in JavaScript. And JavaScript has a better reputation, obviously, right? As soon as you say let's do everything in JavaScript. People will look like JavaScript is a toy language. Undefined is not a function, right? Programming in JavaScript feels like playing Minesweeper as a job, right? So maybe I can convince you that that's not such a bad idea to write everything in JavaScript. The fact that convinced me and kind of was a big change in my perspective was about 5-6 years ago, the same version of JavaScript called ES5, and you will know what this means soon, got adopted by everyone. All the major vendors finally implemented it. So now you had a uniform platform. Before that, you had kind of a patchwork of this browser implements that feature, but this one doesn't. So you didn't have the same platform. But once ES5 got wide adoption, you actually had a uniform platform. That meant that all browsers were the same, right? Things like IE6, IE7 were already dying off, right? Everything else was compatible. And then on the server side, Node.js became popular, right? And now, not only I had a cross-platform uniform environment in the browser, I had a server-side environment that I could just run anywhere. I could develop locally, I could run on a server, and it used the same version of JavaScript. So all of a sudden, my work became pretty easy. The user would give data to the server would display the data through UI, and the user would interact with UI, but the servers would run JavaScript, and the UI would run JavaScript. So for me, it was huge, because all of a sudden, instead of learning different languages and the quirks and trying to become proficient in everything and learning new tools for different languages, I could just learn a couple tools really, really well and use them for everything. And it's a huge productivity boost. I felt like I was in control, like driving a manual, right? Someone actually posted a joke yesterday. Once they have driverless cars, can you get it in manual transmission? Anyway, pay-wise and career-wise is huge. The switch to JavaScript is always rated high on interest, right? There are a lot of job openings, a lot of places you can use JavaScript. So it constantly comes in at the top of programming languages. I think the stats that I've seen recently that were really interesting was in a single day there are more JavaScript projects started on GitHub than create in a month in C++ or other languages, right? In a single day. There is a huge explosion of programming in JavaScript. So this presentation will describe a couple of things, right? I will go over different platforms and what you can do in JavaScript for each one. I will go over the JavaScript versioning process, and then a couple of main tools that you have to know if you want to work in JavaScript. Well, JavaScript is everywhere. It's ridiculous how it completely took over the world. So it started with a browser. It went onto the server through Node.js project. It now runs on desktop, right? So things like Slack, Spotify, VS Code, Atom are all JavaScript projects running on desktop. It's spreading into mobile, so replacing native apps. And it has all these gray areas, things that are not traditionally JavaScript fields, but Internet of Things, right? Like running JavaScript on your little devices, programming robots, some other things that I'll show. So in a browser, JavaScript started as this mechanism for delivering ads, right? And really grabbing your attention. Used to be all inline kind of alerts, event handlers, but it was the original goal, right? That's why it was written. They needed a scripting language to quickly do event handlers. Nowadays, it's more about web applications. So you don't have event handlers. You don't have a markup. Instead, you include your application JavaScript, and you provide maybe a placeholder. And when application starts, it will replace that placeholder with actual DOM content that it will render. Lots of popular frameworks. The big ones, well, React is not really a framework. It's just a view layer, so you have to bring additional tools. But Angular, Vue, Ember are traditional frameworks that not only allow you to render things, but also manage your data, communicate with the server, and things like that. JavaScript not only was spreading, it was actually killing everything in its path, right? So we had the choice, before you could use something called VBScript or JScript, or Google was pushing on Dart, and they're still pushing, but they forgot about it themselves. So these are no longer relevant. JavaScript just completely eliminated the need to learn that. It also kills some awful, truly awful things that were vendor-specific and proprietary, like Flash and Silverlight. And the Java applets are all gone, right? Nobody includes Java applets anymore. But it gives you a lot in return. So think about writing a cross-platform application. Well, you can get a shell pretty easily using a library like Qt. But it's just a shell. If you actually code for the browser, you get a platform with APIs, with browser APIs. And those APIs are pretty powerful, and you get them for free. Things like access to the camera, access to location, now Bluetooth, payment. You don't have to actually implement anything. By coding for the browser, you get that for free. From the browser, the JavaScript is spreading into mobile world. And I hope that it will replace all the native apps. And the reason I hope for that is because a couple months ago, I looked at my update screen on my phone. And I noticed the sizes of applications. So let's say Messenger, right? The update is 226 megabytes. What the hell, right? Like, why is an app for writing and receiving messages itself waiting more than 200 megabytes? And every app is like that, right? Uber, the thing that's supposed to show me a map and call the driver and do nothing else, is almost 260 megabytes. Why? We have a huge problem with this bloat in native apps. And I don't want to download it. And for me, the download is pretty much free. I do it on Wi-Fi. In parts of the world, this download is not only costly, but just unaffordable. So progressive web apps, they take this idea of, hey, if you write a good web application, you can specify what it needs. For example, if it supports offline and needs camera, it can specify it. And then by running it in the mobile browser, you can save a bookmark, and it will behave just like native application. It will have access to the camera. It will have access to the storage, right? And you don't have to download the native app. So things that really make it a progressive web application as opposed to just a page, it has to support offline because the connection is not a given. It has to have native notifications because that's what native apps do, right? They grab our attention. You can write the best platform, but if the apps cannot actually notify you to get eyeballs back into the app, nobody's going to use it, right? And it has to behave fast, right? It has to compete with native apps in terms of their performance. And I think we're at that point where it's not the design or the technology of application, native versus web. It's more of your application design, how you coded it. How does it fetch data? How snappy it feels to the user. The second approach is you code the same way as you code for the web application. That means use React. But then you convert it to the native application. So it's kind of like intermediate solution, but still looks and feels and debugs while you work as a web application, but then you convert it into a native code. In the browser, the JavaScript actually runs in 4 places. So we all know that it runs in the browser, right? That's what our web applications do. That's first place. But then, if you need more computation power, you can start separate threads called web workers, and that's where you can offload long-running computations. You can offload communication with a server. The only thing the web workers cannot do, they cannot actually render anything, but you can render in this loop and just communicate via messages. So if you need more processing, you can run JavaScript in the web workers. There is a new beast in town called service worker. It's like add-on proxy that runs in your browser, completely transparent or unbeknown to your browser thread. It just communicates with the server, but now you can run this JavaScript to actually modify requests, maybe cache requests. So it allows you to do very cool things. That's the third place. And finally, you can run JavaScript in your DevTools and through something called code snippets. And that's a great tool for not only using modern JavaScript, but by doing advanced things. If you want to know more about web workers and service workers, I have a presentation with intro examples and some cool demos. And if you want to see what you can do with those DevTools code snippets, because you can do some cool stuff that will help your career. I have a big blog post with examples, and great for exploratory testing for performance and security analysis. On a server, so we covered JavaScript in a browser. We covered JavaScript, yes. Oh. Well, when you do this, I assume that you want to throw something at me. Okay, Node.js, great product, all right? Person took JavaScript engine from a browser, wrote a little layer, right, that can allows the engine to access file system, access network, and you get Node.js, the server platform. The creator, Ryan Dahl, actually moved away from Node, and he moved to Go, and now he's back, I think. So it's interesting. So basically, you run your server code, and creating a server could not be easier. You just say HTTP create server. HTTP module is built into Node. And then you get request and response. So you can look at requests, like what does it need? You can generate a response and send it back. Could not be easier. And running it just means listening on a port, and that's it. So spinning a server on demand is very lightweight, very fast, very quick. Large enterprises are adopting Node.js in spades. I think because, again, you don't have to have a separate silo for your backend and separate silo for your front end. The same developers can quickly work on a server and one web application. So instead of kind of separating backend from front end, you have a feature silo where a person says, OK, I'm going to deliver user profile editing. I'm going to update the front end. I'm going to update the backend. I'm going to deliver the whole thing at once. So you can do damage on both ends. Node.js is an interesting project, right? The great strength of Node.js is that it's actively maintained. And there is a core, but there are a lot of outside contributors. And every 6 months, you get a new version. So 4, let's skip 5, 6, 8, 9, 10. Every 6 months, you get new one. The odd numbered are kind of work in progress. But all the even numbers have long maintenance schedule. So if you stay with 8, it will be supported for a while. 10 will come out in April next month. It will be supported for a while. So as long as you stick with even numbers in production, you'll be covered for a long time. On a desktop, Electron from GitHub allows you to completely bypass the question of how do I build a cross-platform app that runs on Windows and on Mac. You just grab Electron and you code it the same way as you would code an web application with a built-in Node.js. So for my company, we give you this end-to-end test runner. You want to run it on different platforms, Windows, Mac, and on all the different Linuxes on CI. So we have different platforms. We have different CIs. We build the same Electron application. We run exactly the same code, and Electron automatically delivers the underlying platform for each OS. We don't have to worry about that at all. It's the easiest win, for example, for us to build Windows was the easiest thing ever. Completely bypassing all the libraries, Java, everything. Just use Node. And so our application is a web application running via Electron. And the cool thing here, and I think I'll mention it in the next slide, is that as I told you that I just know a couple of tools really, really well now. I don't have a couple of tools from one language, from one platform, and a couple of tools in another platform. If I want to debug something, I just pop DevTools in my browser, right, in Chrome. So by learning just a single debugger in DevTools, I can now debug web applications, my node service process. I can just listen and debug it using DevTools. And my desktop application is Electron. I just open DevTools right away, and I can debug my desktop application. That's it. I don't have to learn 3 different tools. I can use just a single debugger. Kind of gray area. I used to love Perl. I used to be very good at Perl. I was grading homework assignments and for like large classes in college, and like I took over. Like, you guys don't do anything. Our TAs, you just do whatever you want to do. As soon as everyone submits, the Perl shell scripts will grade everyone's assignments. Great. I hate it now, right? Because when you work with applications on different platforms, every shell is a little bit different, right? Finding a common shell to be installed on every platform is a hassle. So I don't want to do that anymore. So now all my shell scripts, for example, my build scripts, are all using Node.js and using shell libraries that wrap around native APIs. I have only single Node.js script. I can debug it if I want to, right, using DevTools. And they all run on all platforms using the same syntax. Great. I mean, for me, it simplified life so much. And it's clear. It's unit testable, right? It doesn't use special squigglies that are like working Z shell. So we covered where JavaScript can run. Let's kind of look at what JavaScript is. So it's a language, but it's a mistake to call it JavaScript language. The history was that 20 years ago, Netscape was fighting, against Microsoft, and Microsoft has a competitor browser, right? And by giving more power to developers, you can actually attract them to your browser and make them write for your browser. So Netscape needs a way to script things, and so they come up with this language in 10 days, right? Great, hack. But they want everyone to adopt it, right? So the developers actually don't write just for Netscape. So they ask this organization called ECMA, hey, we have this language. It's pretty simple. Can it become a standard? And then other people can code to that standard. So a year later, ECMA organization publishes EcmaScript standard. So the official name of a standard is EcmaScript. That's why it's called ES. And JavaScript is just one implementation. There were others, like ActionScript and Flash, actually conform to the standard, right? Funny enough, JavaScript is a trademark of Oracle, right? And Oracle is evil, so we'll see what that leads to. So when I said 5 years ago, browsers all adopted kind of a common platform. So that platform was a standard that came out in 2011, and it was called 5.1. Nobody cares about 0.1 because floating point, arithmetic. So ES5. Okay, so all modern desktop browsers support that. You can assume that. And it looks kind of like standard JavaScript. You have vars to declare variables. You have functions. Interestingly enough, EcmaScript doesn't actually specify anything about input and output. So it doesn't standardize console object. So using console was always a little bit different in different platforms. There is no file system, nothing. 3 years ago, a major, huge upgrade to EcmaScript came out called ES6. And now you had constants, you had those arrow functions, you had template variables, just a huge list of new things, right? It was, I think, just as large of upgrade as the original language. And you can find like all the examples here. But a year later, there was another standard, right? Another version. and we call it, well, 2016, but it only had 2 features. So there was a huge upgrade a year earlier. Now just 2 features in 2016, like includes in arrays and exponents. I mean, come on, right? Like that's so important, has to be. Last year was a big feature that came out, async await, and a couple smaller ones. But basically every year there is a new standard. And we kind of started calling ES6 to kind of say, this is not ES5, this has error function. But after a while, it kind of gets boring because they're always like 1 digit off from the year. So now we probably should call it EcmaScript 2017, EcmaScript 2018, and so on. So you might ask yourself, well, if there is a new iteration of a spec that comes out every year, like how does this happen? The whole thing is very open source and very public. And you can go to this URL, and the committee from ECMA is called TC39, technical committee number 39. And they have a process document, and that explains in details what's going on. And in just overview, anyone can propose a new feature. Like we can all propose something, right? I don't know why, but everyone can just say, hey, it would be cool if JavaScript had this. And the idea is born, and it's called stage 0. And there are a lot of stage 0 ideas. Most of them are going nowhere probably, but you go to TC39 committee, and you say, okay, I have this cool idea. Here's an example. This is what I wanted to do. And if someone from TC39 says, yeah, that's actually a good idea. Yeah, let's maybe try to make this happen. He or she becomes a champion of that idea, right? It's a member of TC39 committee that will champion your idea. And that's where you write proposals, examples, trying to convince people. Not surprisingly, the committee has all the major browser vendors, because these are the people who will ultimately implement that idea. So they're on a committee. After a while, through discussions, through feedback, that idea becomes crystallized. You might say, it would be nice if every time you use the variables, someone gave me $1 million. That's an idea. But after a while, it gets to be precise. It gets a precise specification. And so every time you use a variable, give Gleb $10, right? By stage 3, you have to have exact API, all the specs. You have to think about all the details possible. And by stage 4, you have to convince 2 major browser vendors to implement it, right? And this could be behind flags. That's okay. But you have to agree. I mean, you have to convince, for example, Microsoft and Apple, hey, implement my cool idea to give Gleb $10, right? Now, that's hard. And that's why it's taken so long, because everything could be specified, but it might not be high on priority list of Microsoft, right? Or Apple, or Chrome team. But once you get that, it's called stage 4, finished. And all the features by this month at stage 4 become a part of this year's standard in June. So some of the finished proposals for the last couple of years are here, as you see, like async functions are here. You see the champions. Sometimes there is more than one. Oh, they're all very busy. And all of them are busy on the internet, right? And all of them love memes and, kind of. Sometimes the work of the committee is very public, right? And if you heard about the smoosh, right, then like it can become a little bit back and forth and like, what were you thinking? And, oh, we were trying to do our best not to break the web. And okay, so the list of things accepted is short. The list of things that are in different stages, from 3 to 2, 1, 1, 1, 1, 1, is quite long. And this doesn't even include stage 0 features. So there's a huge thing in pipeline, but JavaScript of tomorrow will look like JavaScript of today plus a lot of stuff. And you might disagree. I don't see why we needed class keyword, but That's okay. But once you have a lot of features, the actual question becomes, well, what does particular browser implement? Because the browser now implements feature by feature, not just the whole thing at once. What you can do, you can have a little try-catch, and you can try evaluating. And if you get a syntax error, that means, for example, exponent is not supported. So you cannot run that code. And there is a huge table of all the features and which browsers implement that. All the modern browsers that are evergreen, that means they auto-update themselves, like Edge, Chrome, Firefox, they're pretty much compatible, and they're compatible all the way to this year, right? They implement a bunch of features. They implement a bunch of maybe stage 4 and 3 features. But mobiles are really behind, right? And mobiles are usually don't upgrade as easily. If you ever have like Android phone from with older version, you know that getting an upgrade is actually, like a Christmas present. You have a couple as a app, as a web application developer, you have a couple choices what to do with this. You can use polyfills, and polyfills are useful for some of the API methods, like you can polyfill includes if a browser doesn't have it. But it doesn't work with every feature. For example, if you're just trying to use exponent, it's going to crash because there is no polyfill that will actually update the JavaScript parser in the browser. So in that case, you have to rewrite the code to match the old standard that's more widely available. The most commonly used tool for that is called Babel. So you take your modern JavaScript that it's bleeding edge, you run Babel on it, and it changes it to match the old standard. So it becomes longer, more verbose, right? Safer, but it can run everywhere. So we covered where is JavaScript, the different versions. Now a couple of main tools that you have to know if you want to work in this field. So npm registry. So don't write the code, find it. Someone has already written it. It's been growing tremendously, right? It I think has more JavaScript and more libraries than everything else combined. Because there are a lot of modules, some of them could be high quality, some could be low quality. My favorite search engine is npm's, but I think npm registry own website now includes these metrics for like quality, maintenance, and so on. So by looking at different scores, you can actually find which module is high quality, could be trusted, to be maintained well into the future. Creating your own module and publishing for everyone to use could not be easier. You literally just have to start a project and then call npm init yes, and you get the defaults. And then you can do npm publish, boom, everyone can now use your new module by installing it. For formatting and linting, I don't want to argue tabs against spaces. So things like prettier are huge in JavaScript community. But JavaScript is a dynamic language. That means there is no compiler to kind of help you not break stuff, right? So things like linters help to catch silly errors. So this looks like this. So first, you install prettier. Prettier will just format your code consistently. So when you do code reviews, you do not argue about braces and where to put variable names and should you use semicolons or not. And my favorite linter is standard. And these are two different things. So you can install those tools, add them to your scripts. So when you run the test, before the test or pre-test, it will run lint command. Lint will just run standard, and it will try to fix everything that it can fix. And before it runs lint, it will actually make your JavaScript consistent. Example. So let's say I'm writing index.js. Again, there is no compiler. So I haven't noticed that when I'm exporting function from this file, I misspelled add. common mistake: misspellings, variable renames. Normally, I would ship this code, and in production it will break, and people might get upset. But if I run standard, my linter, it will actually give me two errors. It will say add, the function add was never used, and add is not defined. So it will notice that I misspelled variable, and it will say, hey, the first use was never used again, and the second variable that you're trying to use, actually you never declared. So this allows you to catch those silly errors. You have to start testing. You don't have to write tests first, right? Just write them. And you should be running your tests as often as possible, right? I like to run them while I'm coding, so test-driven development. I like to run my unit tests before I do a commit, so I don't push bad code. I like to run them on my server. A lot of choices for unit testing. Tape, QUnit were kind of old school. The new kids are Ava and Jest. Jest is from Facebook. I kind of like it. It's delightful, how we call it. So basically, you add it as a dependency. You can call it. A test looks like this. For example, you're describing add function, so you grab the function, and then one of the tests verifies that when you call add 1 and 2, you expect the result to be free. When you run it, it says one test adds number passes. The coolest thing that Jest kind of introduced into wide community is what's called snapshot testing. It's easy to compute what add 1 and 2 should be, the expected value, right? You can just compute it by hand. But imagine you're actually testing a large, API that actually returns this complicated object. Maybe it renders something. Maybe it computes a big JSON blob. So instead of computing by hand and putting it in your test file, you can just say expect add 1 and 2 to match snapshot. And then you can do it many times. So the first time you run this, it will actually compute the result and then save it into a file separately. So there'll be a file that will look like this. It's just JavaScript, and that's the name of the test and the counter. So the first thing that it computed was equal 3. The second one was equal 50. And again, in more realistic tests, it would be a giant JSON blob, nicely formatted, easy to look at, right? And it would not actually pollute your unit test file. So that's the first time when it actually saves it, and that's it. So it keeps that file, and let's say you actually change something, or maybe your logic changed, maybe your code broke. You still just have to match snapshot. But now when it runs, it actually loads the previously saved value and computes the current value with that. And so if there is a mismatch, it will throw an exception saying, okay, received value does not match stored snapshot. And it will give you, a diff, and it actually knows how to handle common cases like objects and text. And it will give you a really nice message saying, this is what has changed. Your snapshot doesn't match what was before. Really useful nowadays. Everyone kind of, I don't want to say goes crazy about this, right? But is in love with this feature. So there are a lot of unit test frameworks. The snapshots is becoming important. I've written snapshot testing utilities that you can use in other places, not just Jest. But for end-to-end testing, when you actually want to test the deployed system, I recommend our Cypress. It's open source, completely free. It's fast, and there's no flake, and it's just NPM dependency. So check it out when you have a chance. One thing I have to say about this. You want to split your code into separate files. In other platforms like C++, right, you can actually, your compiler takes care of like bundling and compiling everything into the single application. But in JavaScript, you have this as a problem. There is no mechanism specified in EcmaScript how one file can load another file. There's nothing. There's no input or output in EcmaScript. So Node.js, when it was created, needed something like that. And so they came up with their own standard called CommonJS. And CommonJS looks like that. So this file, add.js, it has a function that says, I want to allow other people to use that function. So I'll say module.export equals add. And then another file that actually needs it can say require and a path to my add file. And now you can use that function. Now, it's easy to do on the server side because you can just load that file synchronously because you have file system. You can just pause everything, load, and then continue. Of course, there are two huge problems. Browsers cannot do this synchronously. They cannot block everything waiting for a file that can take milliseconds or seconds to load. So you have to bundle everything. That means you have to somehow put all the files together. There are a couple tools that you can use. And then you include just a single bundle, right? You don't include a head file, or you don't include each file. You just include a bundle. But the second problem that's more sinister is that you don't know which parts of all this JavaScript you actually will end up using, right? If you just blindly include everything, you get this giant shipment of modules and JavaScript that you have to ship over the wire. So your bundle, by being, let's say, a megabyte, will take, first of all, 10 seconds to load, even on a good connection, and second, 10 seconds to actually be evaluated and actually start running, especially on a phone. So you need something better. So now there is a standard. And it's almost, it was part of ES6 standard. It just wasn't implemented yet, right? It's still an ongoing process. And it's called ES6 modules. So instead of using module exports, you declare with export keyword what you want to export from a file. And you use import if you want to use something from this file. So it's a standardized thing. And of course, it doesn't work, right? As always in JavaScript land, some features were implemented, some not. Node, even in 8, doesn't support this. So maybe it will be in Node 10, which comes out next month. And browser support is all over the map, so you cannot rely on this to actually work. In Node, at least, you can use a polyfill that will provide this functionality, so you can use import and export keywords. But in the browser, you have to have, again, to use a tool that will bundle everything. And I prefer to use Rollup and not Browserify or Webpack because Rollup has a very interesting feature. So first of all, it's just a JavaScript dependency. You install it, you give it the name of a first file, and it will trace everything. It will create a bundle, and you just run build, and you'll get your bundle. But the best feature about Rollup is the tree shaking. So imagine you have index.js, and you actually import a couple of things from add, and then, well, add from one file and sub from another file, but you only use add, right? So you never actually use this thing. You never use the dependency. So when you look at the bundle, you only see add. But the tool Rollup went through all JavaScript, and it looked at everything that you required, and it figured out that, yes, you required it, but you actually never used it. So it could actually drop everything that's not used. And the best thing about this is that now, because of modern browsers and the new keyword type module, you can ship both. And the browsers, especially if you put the latest code first, they can actually load this and never load the backwards compatible bundle. So you ship less code with modern syntax for browsers that support it. And everyone else will get the older one, the ES5 compatible bundle. So I hope this gives you an overview of where you can find JavaScript, why it's a good move for your career, and how JavaScript is actually evolving. But it's not everything. There is a lot more than you can do with JavaScript. You can program little devices, you can program databases, you can program. What's most exciting about all of that is peer-to-peer. You can eliminate the server altogether, right? When you do Google Hangout, you're using WebRTC, where your browser is broadcasting not through the server, or not to the server, but to another browser. And you can do it for audio, video, and data. You can create applications that are like torrent without any server, just running from my browser to your browser to your browser. And the more people are using it, as you know with torrent, the faster it becomes. Completely opposite idea from the server. So that's the most exciting thing. But other people are excited about WebAssembly and virtual reality and other things. But who can judge them? So just 3 quick conclusions. You know, it's a true story about JavaScript that is like a pawn that went all the way and became, you know, a queen. It was created in 10 days, yet now it runs everywhere. It became really powerful. It's the most exciting language. It's truly running the modern web. And the modern web, I think, underlines all the modern businesses. There are no old school, you know, by the book businesses. We are all now running, we are all working for technology companies. It's just the company doesn't have technology, it's in its name. There is an enormous diversity of libraries, technologies, tools in JavaScript community. You can find something that someone wrote probably for your exact problem that you're having right now. You just haven't discovered it with the right tool yet. But someone probably has already written it. And the most important thing, as opposed to other languages that are faster, maybe more robust, you know, things like, I don't know, C++, Scala, JavaScript has a unique feature because now it has a working process for improving itself, for iterating. And if any one of you have attended my HTTP talk, right? HTTP has the same improvement process, and that's why it's so good right now, because there is actually a mechanism for making it better. The same with JavaScript. Thank you, and you can find slides on slides.com, and I'll be happy to talk about JavaScript. Thank you. Also, lunch.